Hello and welcome back. This is Sir Carlos. This is still grade 9 chemistry, but now we're going to continue with the second and the third learning competency. So the second learning competency in Science 9, in Chemistry 9, is explaining how the quantum mechanical model of the atom describes the energies and positions of the electron. So kung paano natin gagamitin daw yung quantum mechanical model of the atom in describing the energies and the positions of the electrons. And then the third one is explaining the formation of ionic and covalent bonds. So we're going to start describing how the process is done. If you want to follow through with some kind of reading material, you can get your learner's module, open them in Unit 2, Module 1, pages 14 to 20. And so let's start. Okay, so the first thing that we'll be doing is activity 3, titled electronic configurations. Okay. The objectives are the following. The first objective is to write the electron configuration of the elements in the third period. By saying third period, we are referring to the row, okay, the third row. Remember, period is the horizontal arrangement. It's the horizontal arrangement of elements in the periodic table, in the modern periodic table of elements. And then determine the pattern of filling the orbitals based on the given distribution for the first 10 elements. And then the last objective is to devise rules in filling up the orbitals. The materials you'll be needing are the following: paper, pencil, and the periodic table. And so for the purpose of, online discussion or asynchronous sessions, I tailor fit this to your, for your needs. Okay? So if you are here, you are either one of my students in grade 9, or, you randomly search this video in YouTube. Okay? So, this is an activity that can be done in the face-to-face classroom. However, since we are in the middle of a pandemic, or we don't even know if it's the middle of the pandemic, we can do it. So I tailor-fit this in a way that it can be delivered pa rin online. And so the first thing you need to do is you need to work with your group mates, or you can work with yourself, okay, to write the electron configurations for the elements in the third period of the periodic table. Again, you can work in groups. You can also work individually. And so these are the elements in the third period that I am talking about. So sodium, magnesium, sa may bandang, makikita nyo yan, bandang left, so may left side. And then aluminum, silicon, phosphorus, sulfur, and chlorine, as well as argon. Okay, so write the electron configurations for these elements on your answer sheets or on your notebooks. If you need more time, you can pause this video. If you have decided to continue, that means you're ready for the second part of the activity. For the second part of the activity, you need to compare the electron configurations of the second period, of the elements in the second period, and the elements in the third period. So these are the elements in the third. These are the elements in the second period, whereas these are the elements in the third period. So what you need to do is just compare the electron configurations for each of them. Okay, I'll give you a moment. If you need more time, you can pause this video. If you have decided to continue, that means you're ready to answer the guide questions. For question number 1, do you see patterns in the distribution of their electrons? Can you see patterns? If you need more time, you can pause this video. If you have decided to continue, that means you are ready to answer question number 2. Guide question number 2 is, what are these patterns you have observed? So it's some sort of a follow-up question. If you need more time, you can pause this video. If you have decided to continue, okay, sagutin na natin ang last guide question. Question number 3. What do you think are some rules that apply in filling up the orbitals for the elements or for atomic numbers 1 to 18? So what do you think are the rules that apply in filling up the orbitals for the elements for atomic numbers 1 to 18? If you need more time, you can pause this video. If you have decided to continue, that means you are ready to answer the questions, or you are ready for the answers to these questions. For the answers, syempre, since this is asynchronous and I can't really, I can't really ask you to submit them to me real time, your answers real time. So I'll be giving you some pointers that you need to look for in your own answers. Okay, so in other words, you can check your own work right now and just look for these factors. For the answer to question number 1, the answer is a simple yes. Yeah, so I hope that you got it correctly, because you have a literally 50% chance of getting the correct answer here. It's either yes or no. Okay, so for the answer, for the second question. Okay, so answer to question number 2 is an orbital has a maximum of 2 opposite spins. It has a maximum of 2 opposite spins. So each cell here is an orbital. So maximum of 2 opposite spins. An orbital in the same sublevel is filled with 1 spin before pairing. So as you can see here, for helium, although this was the error that we talked about in our previous video. Okay, so ang mangyayari mo na dyan is mag-fill up mo na siya ng mga upward na spins, okay, for all of these elements. Say for instance, dito na lang sa case ni nitrogen. Okay, so upward spin, upward spin, upward spin, upward spin, and upward spin. And then, kapag meron pang surplus, like say for instance, 7 dapat yung electrons na mag-fill dito. 1, 2, 3, 4, 5 pa lang yan. May dalawa pa. And those 2 remaining electrons are going to have a downward spin. Downward spin, downward spin. Filling the orbitals with electrons starts from the lowest energy level to the highest energy level. So it starts from 1s, and then 2s, and then 2p. In this case, 2px muna, 2py, and then 2pz. Then 3s, 3px, 3py, 3pz. Then 4s, and so on and so forth. The total number of electrons on the outermost energy level is the same as the group number in the periodic table of elements. Take note of that. Yung total number of electrons in the outermost energy level. Okay, halimbawa, in the case of hydrogen, the outermost energy level is 1s. So since it only has 1 electron, the atomic number of hydrogen is 1, and its group number is 1. Okay, so it corresponds to that. The total number of electrons in the outermost energy level, or the total number of electrons, valence electrons. Okay, so they correspond to the group number of the element in question. And then for the answer for question number 3, an electron can be represented by a spin. In filling the orbitals with electron, it should start with the lowest energy level. An orbital in the same sublevel should be filled with 1 electron before pairing. An orbital has a maximum number of only 2 electrons, so as it was said. And I hope that based from your self-criticism, of your answers, you were able to get a score of 3/3. Okay, so if you're my student, do not forget, okay, you're supposed to post your answers in your Edmodo accounts. That ends the first part of this video, activity number 3, electron configurations. The second part is a discussion on the arrangement of elements based on electrons on highest energy levels. In grade 8, you have to recall this, okay? From in your previous grade level, elements were arranged in the periodic table based on increasing atomic number. So atomic number 1 is hydrogen, atomic number 2 is helium, atomic number 3 is lithium, and then atomic number 4 is beryllium. Tama ba? Hydrogen, helium, lithium, beryllium, and then atomic number 5 is boron, atomic number 6 is carbon, atomic number 7 is nitrogen, and so on and so forth. So they're arranged in increasing atomic number. The formula for getting the number of protons and number of electrons is simple. So recall as well that the atomic number corresponds to the total number of electrons you will find, no, total number of protons you will find in an element. Okay, so in the case of tawag doon, a radioactive decay, pwedeng magbago yung number of protons and number of protons and number of electrons. Pwedeng magbago 'yun. Okay, pero if you are referring to elements in the periodic table, the number of electrons and number of protons are the same because the element is supposed to be electrically neutral, and the number of electrons, which corresponds to the number of protons, also corresponds to the atomic number. Ayan. So therefore, the elements are also arranged in the periodic table based on increasing number of electrons and increasing number of protons. Ganun lang naman yung formula, right? And so now, in the case of hydrogen and lithium, they have one electron in their highest energy level. In beryllium naman, it has 2, whereas boron, it has 3. We can now just expect that since merong isang electron ng hydrogen and lithium sa kanilang valence shell or sa kanilang outermost shell, we can say now that both of them belong to group number 1. Beryllium naman, since meron siyang dalawa in its outermost shell, meron siyang meron siyang group number na 2. And then boron is group number 3. Yeah. So the number of electrons in the highest energy level of the elements is the basis of their location in the periodic table. Now, what does that say pa? Since the experimental basis ng periodic table is the chemical properties ng mga elements, knowing the arrangement of electrons in an element will help us understand and predict their chemical properties. Since alam natin na yung basehan ng pagkakasunod ng mga elements in the periodic table are the chemical properties. Alam din natin ngayon kung paano natin sila maintindihan. Okay, we know how to approach the study of elements and how can we use them perhaps in doing some innovative processes in science. And also, we can predict their chemical properties because of their arrangement. Yeah, that's a quick part. Okay, for the second part of our session, the discussion is all about arrangement of elements based on electrons on highest energy levels. The last part of this session is a discussion on groups and valence electrons. Ayan, so this is a group of elements found in the periodic table. These are the noble gases. Okay, you can get your own periodic table now and locate the noble gases. Dali, go ahead. I hope that your periodic table is updated because we already have oganesson or oganesson. Okay, element number 118. Okay, included in our periodic table. So actually, they're working on the 8th period yata of elements. So we just have to stay tuned for that. So the electron configuration of the following elements are the following. So helium is 1s2. Neon naman is 1s2, 2s2, 2p6. Did you see what I did there? Okay, so helium is a noble gas. It is said to be just as stable as the other noble gases. Since it may be quite long if we're still going to memorize 1s2, you can actually write the electronic configuration of an element, of any given element, by applying by using the noble gas configuration. So this is what you would call as a noble gas configuration. Or as far as I am concerned, this is how I asked my class to call it, the noble gas configuration, or noble gas oriented electronic configuration. Para mas maintindihan nila because, daming nga daw nilang pinag-aaralan. And so, next one naman is argon. The electronic configuration of argon is, it says here, neon. So, ano ibig sabihin nun? Okay, so neon is 2s2, 2p6 with helium. So, that is 1s2. So, Argon, the complete electronic configuration of argon is 1s2, 2s2, 2p6, 3s2, 3p6. And so on. So argon for krypton, and then krypton in xenon, and then xenon in radon, and then oganesson has radon. And so, except for helium, all of these elements here, from neon to oganesson, they have their outermost energy level containing 8 electrons. So, lahat sila, meron silang mga 8 electrons in their outermost energy level, aside from helium. Ayan. So, sharing or transferring of electrons causes an atom to have a sequence in its electronic configuration that is like the electronic configuration of the nearest noble gas, as I told you a while ago. So, say for instance, in niobium, in the case of niobium, it takes the electronic configuration of radon, which takes the electronic configuration of xenon, and xenon takes the krypton, takes argon, and then neon takes helium until it begins with 1s2. Okay, so the complete electronic configuration of niobium, we can say it as 1s2, 2s2, 2p6, 3s2, 3p6, 3d10, 4s2, 4p6, 4d10, 5s2, 5p6, and then 4f14, and then 5d10, 6s2, and 6p6, 5f14, 6d10, 7s2, 7p6. If you see an error in this slide, I'm very much open for that. Kasi syempre, in psychology, we have that idea of closure. Okay, so no matter how many times I look at this slide, it doesn't have an error for me. So I'm very much open for constructive criticisms. If you see an error in here, you can share it in our comment section. I'll work on that. Okay. And the sharing or the complete transfer indicates that the atom has attained stability. Either the sharing or the complete transfer of electrons leads to the formation of compounds. So compounds is a term that we use to refer to the combination of elements. Say for instance, combining hydrogen and oxygen, you can produce water, so H2O. You can also produce hydrogen peroxide, which is H2O2. So even though both of those liquids, they have hydrogen and oxygen in them, since one of them, water, has only one oxygen, the other one has two oxygens, they will be having different behaviors. So yung isa, H2O2, is hydrogen peroxide. It's used as a disinfectant. Water can also be used as a disinfectant, pero at least you can drink it, okay? Unlike hydrogen peroxide, which is something that is not it's supposed to be ingested, as far as I know. As far as I know. Again, so you are now having the idea that the arrangement of these elements in the periodic table is not per chance. Hindi siya parang ginamitan ng die. Okay, hindi siya ginamitan ng die. By chance yung pagkaka-arrange, not like that. The vertical arrangement of the elements now is what we call as a group or family. Okay, yun namang period, as I mentioned kanina, is the horizontal arrangement. The other name for a period is a series. So we have 7 series, 1, 2, 3, 4, 5, 6, 7. Barium continues with lanthanum, and lutetium, tapos starts again, continues with hafnium. Okay, so radium continues with actinium, and then dito siya LR, and then rutherfordium, until matapos siya sa oganesson. And so the numbers on top of each group or each family represents the group number. Okay, and then it is based on the number of valence electrons in the elements and the group has. Valence electrons are the electrons found in the outermost energy level. So I hope you picked that up by now. So halimbawa, for hydrogen until francium, lahat sila meron silang own isang electron in their valence shell. So meron silang isang valence electrons. Okay, tapos si 3A naman, lahat ng nasa 3A, they all have 3 valence electrons. And so that ends the last part of this session. It's a discussion about the groups and valence electrons. So far in this session, you were able to, you were exposed to the following. You did, or you went through the following parts. So the first part is an activity number 3, electron configurations. The second part is a discussion about the arrangement of elements based on electrons on highest energy levels, and then the last part is a discussion on groups and valence electrons. You successfully completed this PowerPoint already. Okay, so receive some further instruction from me during our synchronous sessions. I hope that you are also through with all of your modular tasks. This is Sir Carlos, and this is also the Knowledge Catalog, Education Solutions. I'll see you in the next video.